Hey, everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today we have 729, my calendar 1. Today was a easy day, and literally, I just kept it easy. I think I ran 6 miles or so, something like this, easy. But I did have did a fun 400 meters. I did a relay race with a couple of people, except for it was a beer lap where we're supposed to chug a beer and then run a lap. It did not go well, so I'm not 100% today, but it was fun, and you have to have a little bit of fun. I was going to say something about yeah. If you're watching, I think I mentioned this a little bit yesterday, but I might not have actually. I missed one detail. Is that I went to the Liberty game yesterday, the New York Liberty, the WNBA game, and Ja Rule was there, which I am old enough that it kind of brings me back to those days of like those music. Let me know in the comments what music inspires you, because today I feel like that's all the music. Like it brought me back, and then I'm just like listening to all that music from that era. So just like I don't know. So if you're watching, let me know what comments do you code to, or at least like just kind of jam to. Anyway, let's take a look at today's poem, my calendar 1. I feel okay right now, so I think I'm going to do an extra poem, a bonus poem review after this. So definitely stay tuned if you find this one too easy. Okay, let's see. My calendar 1. How do they know that they're going to have a sequel before it? Like if you're the first poem, how do you know it's going to do good enough that you have a second one? Mystery. Anyway, you're implementing a program to use as your calendar. You implement. Okay, well, awkward phrasing. You can add a new event. Sorry, I'm just being dumb. You can add a new event if the adding the event does not cause a double booking. A double booking happens when two events have some non-empty intersection, some moment that is common to both events. The events can be represented as a pair of integers start and end that represents a booking on the half-open interval start. Close start, open end, right? The range of the real number x such that okay, well they explained it anyway, so I guess that's good. Implement my calendar class pass. Okay. So it's just basically maintaining intervals. Okay. Yeah. Right. So there will be. So yeah, looking at the constraints, there are 1,000 calls, so that means that we can get a little bit funky if we really need to. The start and end is 10 to the 9, so that means that we can't do anything, to take advantage of that per se. And of course, this is given is in a object kind of thing. The main point of that is so that is a query, right? You have 1,000 queries, and the difference between this and sometimes you get problems where you get queries all together, but those queries you can process them in any order you want, right? You might not think about it that way, but it's true, right? You can process them at any time you want. And some problems which it's a little bit dubious, honestly, they expect you to do it, right? But in any case, if they structure like this, then you have to do them in order. So that's basically the idea. Yeah, I think this is like a segment a segment thing, right? We have the start and end segments. I'm thinking about the number of ways we can do this, right? So I think the straightforward way maybe to kind of use a binary search tree or something like this to just kind of search the left to the right and see if anything intersects, right? Another thing that you can do is with I guess you can't because I forgot that. I'm just highlighting. That's what I was thinking. And yeah, I was gonna say with what is that tree? I was gonna say you could also do this with what is that tree that everyone does with the bits? Larry, what are you doing? Today my brain is not in it, I suppose, or like I just don't have a brain. What is it? It's not the binary index tree. That's the word I was. I don't know why. I mean, I know what it is. I just Okay. But yeah, I was gonna say you could do a binary index tree and then just kind of get to see if they intersect. Of course, I forgot that in any case it wouldn't work because start and end is less than 10 to the ninth, which is too big, right? And usually you can say, oh, but there are only 1,000 queries. You'll be able to pre-process the queries such that you do path compression, or not path compression, coordinate compression. Then then everything will be within 0 to 2,000 or something like this, and it'll be fine. But again, we have to force to do this live, so we can't do a binary index tree, right? So okay, so here the way that I'm going to do it with sorted list, the idea is that and I'm bringing up the drawboard right now, so I'm just pausing it a second. Let me draw it to explain it. So yeah, so the idea here is that, okay, well, I mean, so you have a timeline, right? You add them, you go, okay, well, this is booked, say, right? And then the next time, there are really only a couple of ways you can book a thing, which is that, or a couple of ways you can overlap, right? One is that you have this, another one is this, and then the other one is this. And that's pretty much, okay, one more, which is that they're both inside, right? And that's pretty much it. And I think if you kind of account for these cases, it should be good, right? And yeah, maybe I didn't explain this, but yeah, but this is just, this is the new query. These are the new queries coming in, and they just overlap in these ways, right? So, okay. So how do we want to do it? I think in Python it makes sense to do it with whatchamacallit. Man, I am just sorry friends, no brains today. Sorted list, sorted containers, sorted list. Like in other languages, I would just use the equivalent of some sort of tree data structure, or even like what's it called, a set in C++, an ordered set, so that you can do the range binary search, right? Which is the most important part. Yeah. And yeah, and then we just have this where we create it, right? So then add, we just have to basically think about how we do it. Yeah. I'm trying to think, right? I'm trying to think what is a think, right? So basically we have this thing. I was gonna say that we can binary search for the left and we can binary search to the right, right? And then just see how many things are in between. Let me change the colors real quick actually. So you binary search to the left, binary search to the right, and then colors in between, right? And then see how many things are in between in a prefix some kind of way. It's just this index minus this index, and here we will have overlap of 1. And if we look at this one, we will have overlap of 2. And this one, we have overlap of 1, right? So in those cases, I think that's like a easy way of doing it. But then you have this case, right? Where, okay, if you binary search, they'll be equal. So then, but you just have to do one more check, I think, just to check the previous index. And from that, we can get this thing. So I think that should be good. So let's, yeah. I think the only thing that has to be careful is that this is, the boundary is like open on or half open interval. So just have to be a little bit careful. But I think you don't even need to store the interval. So I think that's fine. I think we just have to be careful. Because the reason we have to be careful is that if we store end, if we store n and we have another interval starting at n, then it doesn't go, right? There are a couple of hacks you can do this actually, and maybe we'll do it, but because I don't like the half open, just because I think there are a lot of more edge cases. So because now you have to do if you do a bisect left, it counts the last half of a segment, right? So yeah, okay. But the way that I'm going to do it is just by cheating, I think. So what I was going to do is that, okay, actually let me bring this back real quick. Is that because again, because here this, so what I'm kind of struggling a little bit and try to think through real quick. Actually, let me just delete everything and try again. Right? Is that okay? Let's say we have, okay. Let's change the color real quick. Let's say we have, you know, the thing, and then we have, this is a thing that we added previously, and then now this side is actually open, right? So then now if we try to add a new segment with this, I'm just trying to think through all the cases where, like, you know, there could be a lot of things where it ends here or something like this, and it's just very like you know, it's very easy to do an off by one for that reason. So that's, oh, I didn't put it on the screen, my fault. But anyway, yeah, if I erased it, then, you know, you have this line, the timeline, and then the black part is what we already have in the system. And what I'm saying is that for here, on the open side, we have to be careful so that, you know, these don't overlap. Otherwise you're just gonna have a bad time, right? Of, like, you know, versus, and then here, how do you differentiate this versus just like slightly more, right? So you have to be careful about stuff like that. And there's a way to kind of think about it. The way that I do is that because these numbers are integers, right? Because they're integers, that means that you can fake being closed on both halves, both sides, by doubling all the numbers. Because when you double all the numbers, then now, if you kind of, let me bring back the thing again and remember to put it on. If you double all the things, you can imagine that now we have a fake half a distance to the left that is closed. So then now these don't overlap, right? These searches won't overlap. So that's basically the idea. You could also do it by divided by two, or you can do two things, right? You can do, say, like, you know, start is equal to start, no change, and n is equal to, like, you know, n minus 0.5, which is a little bit clunky, right? Because we're doing with integers, now we're doing with floats, which is a little bit scary. So what we do now is just multiply everything by 2, right, on both sides. And now this is this by 1, right? And then you can say, yeah. Oh, well, not quite yet. After you take it out, yeah. So then that makes it a little bit easier to handle with the boundary conditions, right? So then now, yeah, we can do the search, right? So let's say L index for left index, to maybe table naming, I don't know, is bisect left of start. We have right index is equal to self dot we bisect right left of n. So then if if they're not the same, that means that a previous number is already in the sorted list, and then they intersect, right? Because if they're not the same, that means that there is an index number that is in between them, and they exist, and it's no bueno. So you return false. Otherwise, what we want to do is, if they're the same, you still have to double check, because that's the case that we talked about where, oh, I guess I erased it. But the case that we have to talk about is the case where you have something in the middle. Here, this will give you the same index of, I guess, this one. So then we just have to check. Yeah, I mean, we definitely have to check. But I think my initial idea is a little bit lazy, because what I was going to do is just what I was going to do is just add just store the endpoints. So I don't even care about the segments, because here if we overlap with any of these endpoints, it's already bad, right? But we do have to overlap with a segment for this case, I suppose, because to differentiate between you know, this case, another similar case where you have maybe I'll write on the bottom, where you have like something like this versus this case, right? Because here now we have the previous and the next, but yeah, they're not the same, right? So I think that's basically the idea How do I want to do it? I mean, yeah, I mean, I think we just store the prefix is probably fine. Like we store whether this is the beginning or the end. I think we're fine. Because here we're getting the one that's right before, and by definition, or the invariance that we're trying to hold, there will be no overlaps, right? So that means that these are really the only two cases, because there are no segments that would overlap with each other in the data set. And basically, and by pigeonhole, right, we also means that like we already did the case where there's nothing that overlaps either only one way, so or even inside. So that means that by definition we only have two cases, which are the ones that we have on screen. I do have it on screen, right? Yeah. Have on screen. So that means that the one that's previous is going to be either this one or this one. So we can check. So then what we can do is just by adding a +1 -1 thing, right? So then now the L index, so L index in this case is going to be actually, did I say up on screen? Yeah, L index is actually the next one, because that's just how binary search works, right? It goes to the next one. So here, maybe we can do something like if L index is greater than 0, because if it is equal to 0, then we're done, right? So okay, so maybe if it is equal to 0, we return true and we live happily ever after. Otherwise, oh, I gotta take this off. Yeah, I mean, I just wrote this code, so it's not that I haven't done yet. Otherwise, then now, let's say left is equal to L index -1, right? So we have self dot right? Oh, whoops, the other way. So left is equal to this. Except for it also has whether it is open or closed, meaning it's on the left side or the right side of the thing. So yeah, is left maybe. I mean, this is just an X, but we don't even use it. We don't care what it is. And then if it is the left side, then that means that the next number is going to be right side. So then that means that we are no good, right? Otherwise we return true. But this return true is a little bit not quite yet. So maybe we should write the reverse of this so that it can be something like this. Right, so that's more accurate. And the reason why is so that we can actually add it, right? So then now, oops, we're going to add start 1 and then add and -1. I think we're, oh, is left. Okay, so 1 and 0, I suppose. Yeah, and we have to change these to yeah, to tuples. I think this is fine, because if they're equal, then you're no good anyway, I think. I don't know. I think this part, it's a little bit sketch, but let's kind of give it a spin. I think the idea is directionally correct, but maybe there's a silly edge case that I'm just sloppy about. I think, okay, I mean, this is actually good, but I do want to see really quick what the underlying status structure is. I mean, I'm sure it can get more complicated, but you know, 29 for, okay. Yeah, and you can't really, the way the input is set up, you can't really put anything between 39 and 40 anyway, so it's effectively good. But all right, let's give it a quick submit. Oh, okay. The R was that, you know, I saw previous solutions, I got multiple wrong answers. I was like, uh-oh, Larry, you're in for wrong answers again. But oh no, today I did okay, I did Gucci. So I'm very satisfied about it. I'm curious what I did previously. No, I guess I did the same thing with sorted list. And I did what is tuples? Why did I write it like this? But I mean, seems like I actually had the same idea, but I mean, I had some silly mistake apparently. Oh, by moving it to 1, so I didn't do it that. So I guess that's the reason. And I was trying to fix it, I suppose, 3 years ago, and then oh, I guess I fixed it without by adding more edge cases instead of doing the hack that I did today with the doubling. How about the other thing? I guess I didn't do this hack in the previous 2 times. But yeah, what is complexity here, right? These are effectively binary searches, so they're, log n time. These are log n time as well. So each query is just log n. We don't really care about the input, and it doesn't overflow because 10 to the 9 times 2 is still an int, right? I mean, even if you're using another language, obviously in Python, it doesn't matter that much until you run out of memory or something silly. But yeah, that is all I have for today, though, for this problem. Thanks for watching. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.